Good morning, students. Welcome in HCP practical. Today I will start the experiment number 15 to evaluate absorbent cotton wool IP. Pure concept: absorbent cotton wool and its uses, then purity and storage condition. Now see the absorbent cotton wool. What is the absorbent cotton wool? Absorbent cotton wool is also known as surgical cotton or cotton wool and mainly used for the medical purpose in hospitals, nursing homes, dispensaries and at home for the first aid, then etc. Then because of its property of high fluid absorbency, it is better known among masses as absorbent cotton. Then uses of the absorbent cotton wool. The absorbent cotton wool used for the surgical dressings, cosmetic purpose, etc. It is mainly used for the medical purpose in hospitals, dispensaries and nursing homes to absorb the body fluid for making conventional type of the sanitary napkins and pads. Then storage condition of the absorbent cotton wool. Absorbent cotton requires particular temperature, humidity or moisture and possibly ventilation condition. Being strongly hygroscopic, absorbent cotton readily absorb all type of moisture. Okay. Then new concepts test to be complied by absorbent cotton wool IP. Then learning objectives, intellectual skill to understand the concept of the different tests, then to interpret the significance of different tests. Then motor skill, ability to examine the cotton fibers under the microscope and UV light. Then ability to interpret the chemical tests, ability to observe names. Okay. Then apparatus, glasswares and chemicals. Glasswares, test tubes, then stoppered conical flask, stoppered measuring cylinder, then borosilicate glass, then beaker, then glass rods, glass plates, then microscope and ultraviolet lamp. Then chemicals, absorbent cotton wool, iodinated zinc chloride solution, then dilute phenolphthalein solution, then methyl orange solution, sulfuric acid, water, then preparation of iodinated zinc chloride solution, that is dissolve 20 gram of the zinc chloride powder and 6.5 gram of the potassium iodide in 10.5 ml of water. Then add 0.5 gram of the iodine and shake for 15 minutes. Filter if necessary. These are the preparation of iodinated zinc chloride solution. Firstly, dissolve 20 gram of the zinc chloride powder and 6.5 gram of the potassium iodide in 10.5 ml of water. Then add the 0.5 gram of the iodine and shake for the 15 minutes. Then filter if necessary. Then stepwise procedure. Raw cotton fabrics are treated with various chemicals to remove natural waxes, impurities and foreign substances, and then bleached or cleaned to achieve absorbent cotton. Chemically, it contains pure cellulose with 6 to 7% moisture. Cellulose react with iodinated zinc chloride solution to give stable complex of violet color. The sample of absorbent cotton wool IP is included. The sample of absorbent cotton wool IP is insoluble in zinc chloride solution. Some fluorescence chemical substances may remain in the absorbent cotton due to improper cleaning of raw cotton, which gives the some fluorescence. Naps are small. Then Naps are small tangled masses of fibers visible to naked eye, which can be observed in thin layer against light. It should not contain more than the 500 naps per gram of absorbent cotton wool. Evaluation of absorbent cotton wool as per IP 1996. Then first is identification test. A. Examine single fiber of absorbent cotton wool under the microscope. It contains single cell about 4 cm long and 40 wide in the form of flattened tube with thick and rounded wall and often twisted. Then B. Take the sample of absorbent cotton wool and on glass side and treat it with few drops of the iodinated zinc chloride solution. The absorbent cotton fiber become violet. Then C. Take 0.1 gram of the sample in borosilicate beaker and add 10 ml of zinc chloride solution. Heat to 40 degrees Celsius and allow to stand for 2.5 hours with occasionally shaking. Okay, the fiber do not dissolve. Then second, test for acidity and alkalinity and surface active substances. Take 15 gram of the sample in a stoppered borosilicate flask. Add 150 ml of water to it and macerate it for 2 hours in a closed borosilicate flask. Decant the liquid and squeeze out carefully the residual liquid with a glass rod and mix both the liquids. Use the same filtrate for test for acidity, alkalinity and surface active substances. In that first, test for acidity. Then B, test for alkalinity and test for surface active substances. Now see the first, test for acidity. Take a 25 ml of filtrate in borosilicate glass beaker. Then add 0.1 ml of dilute phenolphthalein solution to it. The solution does not show a pink color. If the solution show pink color, indicate presence of acidic content in it and vice versa. Then test for alkalinity. Take 25 ml of filtrate in a borosilicate glass beaker. Then add 0.05 ml of methyl orange solution to it. If the solution shows pink color, it indicates the presence of alkaline contents in it and vice versa. Then test for surface active substances. Take 25 ml of graduated ground glass toppered cylinder with external diameter of 18 to 22 mm and rinse it with sulfuric acid and then with water. Take 10 ml of the filtrate of absorbent cotton wool in the graduated ground glass toppered cylinder. Shake vigorously 30 times in 10 seconds. Allow it to stand for 1 minute and shake again for 30 times. After 5 minutes, the height of the fourth does not exceed 2 mm above the surface of liquid. Then next is fluorescence test. Prepare a layer of absorbent cotton on the glass plate having a 5 mm thickness approximately. Then examine it under an ultraviolet lamp having a maximum output at 365 nanometer. It shows only a slight brownish violet fluorescence and few yellow particles. Now more than a few isolated fibers show an intense blue fluorescence. Then test for water soluble substances. Boil 5 gram of the sample with 500 ml of water for 30 times in a borosil glass beaker on gas. Stir frequently and replace the water lost by evaporation. Decant the liquid into a beaker and squeeze the residual liquid from the material carefully with a glass rod. Mix a liquid and filter exact whilst hot. Evaporate 400 ml of the filtrate and dry it residual to constant wet or at 105 degrees Celsius, the water soluble substances of absorbent cotton wool should not be more than not 5%. Then last one is test for naps. Spread thin layer of 0.5 gram absorbent cotton for area of 450 square centimeter, then uniformly between two glass plates. View by the naked eye under transmitted light. Repeat the test 3 times. Then absorbent cotton wool does not show more naps than about an average of 250 for 3 tests. Okay, these are the tests. Then here are the calculation part of this experiment. For test for water soluble, weight of empty borosilicate beaker, that is X. Then weight of borosilicate beaker plus filtrate, that is Y. Then weight of borosil beaker with residue after drying to constant weight at 105 degrees Celsius, that is Z. Then weight of the water soluble substances, that is Z minus X. Okay, and then here are the observation table, name of test, then observation table, observation and inference. First is identification test, a single fiber with iodinated zinc chloride solution, then with a zinc chloride solution. Then test for acidity, test for alkalinity, test for surface active substances, fluorescence test, then test for water soluble substance and test for naps. Okay, then result, write down here the result of your experiment. Then these are the questions of this experiment, is most important in point of view exam. Okay, here are complete the experiment number 15 to evaluate absorbent cotton wool IP. Okay, I will stop here. Thank you.